Okay, so this is the third way to check. This one's a little obscure, but this might be the fastest one. So if you like it, this is going to be the time saver. This is something called a normal probability plot. It's option 6 for the type of graph on your calculator. So here's what I'm going to do. Last thing I did was histogram. I'm going to go back to stat plots. So second y equals, where I'm setting stuff up, and I'm going to change the type of graph from histogram. And this is bizarre, but I'm trying to get to the very last one here, number 6. So once I get to the histogram, I actually have to scroll further to the right to get to the next row and all the way over to the last guy. This is a normal probability plot. What it does, it's going to list your data values themselves. So it's going to have the fridge capacities in the x-axis. And then the other axis is going to be z-scores. So how far above or below mean relatively these guys are. So each dot will be a fridge and how above or below average it is. And this is just asking you where it's your list. Mine is list 1. And then the other one's asking you, do you want to put the data values on the x-axis or the y-axis? So I tend to stick with this guy. So I'm going to keep that. And then I am zooming. Zoom problems only happen with histograms, so I'm not worried about anything else. And then the idea here is you're looking for a linear graph. A normal probability plot is graphing every single fridge and its z-score. So the idea here, if I trace, is that this fridge has a 12.9 cubic feet capacity and its z-score is negative 2.2. It is the smallest fridge, right? It is far below average. And then if I just kind of jump around a little bit and trace another one, this is a fridge with 15.1 cubic feet capacity, and that's a z-score of negative 0.71, so it's kind of close to the mean. And then notice these guys kind of pile up. So in a normal curve, a lot of stuff's in the middle, right? 68% of your stuff's here. And then on the tails, things get sparse. So there's not a lot here. So there are spaces between my dots, and that will happen at the edges, but the middle's kind of packed. So if I try another one, now I'm really so I'm real close to the mean. I'm at 16. My z-score is 0.03. So basically the mean was 15.8. I'm real close. And again, if I keep going, I'm now up here. I'm in something that's above average, a 17.4 cubic feet fridge. Maybe I want that fridge. I don't know. It's a z-score of 1.29. So that's what this is doing. So if you have a straight line, when you look at your normal probability plot, is the data normal can be translated into, is the normal probability plot linear? And the answer for this data set would be yes. I find this really simple. It's fast. I don't have to you do have to sketch it, but so if you're sketching this one, what you would do is, this tracing was helpful, right? You would give me an idea of what the data value variability is about. So I had a 12.9, that was my minimum. Maybe put the maximum on your x-axis. It was 18.4. All right, and then the z-scores, they go from like negative 2.2 to positive negative. Yeah. So that's the range of my z-score. So just put the maximum and minimums on both of those to basically document that you actually check this graph. This is not a hypothetical graph, which it totally was. But then this is about this particular data set. In fact, if I write fridge capacity, that should cover my butt. Okay. So now it's about the fridges. But the idea with this graph is you're looking for, basically, is the data piled up in the middle? Is it the normal probability plot? This graph needs to be straight. You're more interested in the center of this graph, so you're focusing on this pile of stuff here. If a few of the dots on the edges are not completely part of the straight line, that's not as much of a concern as if the middle itself was not straight. So for example, here's a normal probability plot for something that is strongly skewed to the left. The idea with that is you have lots of data above mean. And by the way, skewed left, the mean's a little low, right? So the z-score of 0 would be over here. So most things are positive z-score here. And they might, just like that's going to be what's happening. And very few data is below the mean with negative z-scores. So what I'm going to see is sparsity here. I don't have a lot of negative z-scores. And then I see lots and lots of data very, very close together. So what I think of visually is the middle of this x-axis is not where the middle of the dots is. There's very few dots below and very many above. And then this is the curve we're talking about, right? So you'll be seeing a curve instead of a straight line if it's skewed to the left. So if the normal probability plot is curved, it's not a normal distribution. So if it's curving the other way, then it's going to be skewed right. And then heads up, guys, homework over the weekend is to wrap up these problems. But then coming up next week and already up in Google Classroom, should you want to get started, Chapter 2 review problems are Monday night's homework. And chapter practice tests is Tuesday's homework. So if you want to get a head start on those, try it.